Okay, so welcome back, and now we're going to introduce the theorem of convergence of a power series. So the power series is going to fall under one of these cases, okay? So it says consider the power series given by this general form. It says the power series will satisfy exactly one of the following properties. Okay, so it will only satisfy one. Okay, either one, the series converges at x equals a and diverges at every other point, every other value of a. Okay, two, the series converges for all real numbers of x. Okay, so there's no restriction on a. So it converges everywhere. Three, there exists a real number r greater than 0 such that the series converges if the absolute value of x minus a is less than r and diverges if the absolute value of x minus a is greater than r. For all values of x where the absolute value of x minus a is equal to r, the series may converge or it may diverge. Okay, so now a couple of things. For power series that fall within this third case, okay, we say that r, because again this here is describing an interval, right? So excuse me. Sorry. So in this interval, what we're saying is that here we're saying that x minus a is less than r or greater than negative r. Okay? Or in other words, if we add a to both sides, we're saying that x is in this interval. And so we call this interval the interval of convergence because we know that as long as it's inside that interval, then it's convergent. Okay, so all values of x that are inside this interval. So that's called the interval of convergence. Now, r, and if you take that interval, the length or the range or the size of that interval is 2 times r. Because I'm subtracting r and I'm adding r from the center, right? That's why a is the center. Okay? So if I am adding or subtracting r, then my length of the interval is going to be 2 times r, which means r is called the radius of convergence. Okay? So again, for example, let me give you an example here. Based on this theorem, okay, so if I use this one, right? So this one here is convergent when the absolute value of x is less than 1, right? Which means that the radius of or not the radius, but the interval of convergence is from -1 to 1. That's the radius of convergence, okay? Now, the range of this thing is 2, right? Which implies that the radius of convergence is equal to 1. Okay? And obviously notice that this is centered at 0, so a is equal to 0, right? Okay? So, in other words, remember this is x minus a. Right? But in this case, a is 0, so it just is absolute value of x. But again, we started with the idea that this is a geometric series, and it converges for all values where x is the absolute value of x is less than 1, because remember, the absolute value of r, right? Oops. For a geometric series is convergent when r, the ratio, the absolute value of r is less than 1. Okay? Okay. That's it. Have a great day.